How engineers solve traffic jams. Hello, and welcome back to Civil Mentors. Have you ever wondered how engineers solve traffic jams? Congested highways are a regular issue that all drivers must struggle with. It is a problem that generates a lot of tension and unneeded irritation, whether traveling to work or taking a leisurely drive around the city. While it is still a significant issue, many engineers are devoting their time and energy to identifying why and how this problem arises and what they'll do to make it more controllable for drivers in everyday life. Before we begin, if you are new here, make sure to subscribe us and turn on notifications to never miss any updates. Rising road congestion problems. As more people began to own personal cars, the demand for effective road congestion control grew. Roadways across the United States are required to become more adjustable and acceptable for drivers, as observed in recent disturbing data that pushed civil engineers to devote more time and attention to the problem. Road congestion grew by 6%, with the average driver wasting up to 200+ hours of travel over the course of a year. This was an average of traffic hours, with some cities doing better and other cities doing worse during the year. The worst city for traffic congestion was reported as Los Angeles, where the typical driver spent up to 167 hours per year stuck in traffic. At the bottom of the list, San Jose did considerably better, with drivers spending only 81 hours per year stuck in traffic. Researchers are investigating the fundamental causes of traffic congestion and how they might be relieved to tackle this problem. Proposed plans. Fixing two-lane highway traffic and safety conditions is important to the traffic, which has received major research attention in the previous decade. To improve traffic safety performance under current conditions, several cost-effective and proactive alternatives, such as low-cost treatments and highway safety monitoring programs, have been created. Based on the suggested assessment criteria, potential causal factors are expressed, and key countermeasures against bad driving conditions such as abrupt bends, steep slopes, continuous downgrades, low sight distance, and inadequate clear zones are developed. 5 low-cost engineering innovations were adopted expressly to increase two-lane highway safety. Smart road design. Strategies are being explored to add more functionality to the actual road surface, which might improve traffic and give safety elements that would minimize not just injuries and casualties, but also accident scenes that cause congestion. A piece of roadway in the Netherlands has been transformed into a trial area for smart highway features, as one example. The initial phase involves simply mixing the solar-charged photoluminescent powder into the road paint to make lane lines shine in the dark at night, increasing visibility in a region where lamps are frequently shut off late at night. Temperature-sensitive signs on the road surface to inform drivers of weather situations, wind indications, and even embedded inductive coils to recharge electric cars as they pass over are all suggested improvements. Solar roadways, which is being designed by a husband and wife partnership, is another unique road surface invention that is getting popularity in the United States. Solar cells have been incorporated into panels that have been blended and utilized as highways by Scott and Julie Broussard. We're constructing solar panels that you can drive on. They were awarded a contract to test their system in an Idaho parking lot, and the project was completed in 2013. The original prototype's performance was unsatisfactory, but the company is pressing through with testing along a section of historical Route 66 in Missouri as of 2016. Despite its rough start, engineers, renewable power investors, traffic planners, and other experts have praised the concept. As demand for alternative energies and electric cars grow, the concept may receive more attention and implementation. Pavement markings. At the general parts, night performance pavement markings like yellow lane lines and white edge lines were painted. At the junctions, guiding lines, wording, crosswalks, and symbol markings were installed. Sharp bends or sites prone to accidents were marked with thin red lines painted vertically. At lane boundaries and lane mediums for walkers, optical illusion deceleration markers were painted to inform vehicles of unique geometric situations. Alternative transportation infrastructure. Towns and infrastructural planners have realized the need of providing the infrastructure required to assure the safety and efficiency of alternative transportation systems to boost their use. Cycle paths, carpool lanes, bus-only lanes, bus tunnels, tram or streetcar lines, and other amenities are being built in cities across the United States and around the world. The degree of separation between these sorts of designated alternative transit infrastructures and normal car lanes, according to an article gathered by Crowdsourced Transport, increases the degree of effectiveness projected. As a result, entirely separated lanes or exclusive areas rather than just painting lanes or signs on existing pavement are more successful in reducing traffic congestion. Over the next few years, transit design will become an increasingly important aspect of urban planning and regeneration activities. Roadside barriers. Let me tell you that runoff road collisions accounted for nearly 20% of all accidents on the roadway. In many particular portions along the highway, 15,137 meters of barriers were installed or changed based on the degree of roadside danger, accident rate, operation speed, the volume of traffic and composition, and landscape need. One of the most important strategies we used was the forgiving design principle. In other situations, however, barrier equipment was required due to terrain characteristics. At portions of small, continuous horizontal bends and regions with a high frequency of side contact accidents, a total of 2,850 meters of high-strength concrete blocks were fixed beside cliff edges. At severe horizontal curve parts, serrated concrete blocks with light look were created for guidance, resulting in fewer collisions. At cliff portions, windrows, and high concrete blocks with insufficient earth pressure outside of the shoulder, a total of 5,158 meters of curved beam barriers or metal guardrails were constructed. Downgraded portions with greater operating speeds and severe impacts of rollover accidents were selected for A-level corrugated beam barriers. For renovated areas with a decreased risk of collisions, B-level barriers were constructed. Outside of the shoulder, a total of 7,129 meters of cable barriers were installed. To make obstacles more visible, yellow reflectors were put on them. A-level protection barriers were installed in locations with a history of rollover accidents or higher risk coefficients, whereas B-level cable barriers were installed in areas with no history of rollover accidents or roadside shallows. Public transportation investment. The Public Interest Research Group of the United States published in-depth research highlighting the need for more investment in public transit across the country. Increasing public transportation use has been cited as the way to reduce oil consumption, traffic congestion, and our nation's environmental imprint. There have also been suggestions of the improved quality of life and cost savings that come with not having to own a vehicle. Investing in public transportation will also stimulate employment development more effective than investing in highway maintenance or infrastructure projects. While city planners and local governments routinely analyze major public transportation overhauls due to perceived high costs, often less is more. Even current public transportation infrastructures might be reimagined to provide entirely new possibilities that not only address a wide range of pressing issues, but also give the capacity for expansion for towns, cities, states, countries, and beyond. As a result of a convergence of several elements, the area of transportation engineering and innovation is expected to accelerate to new heights of significance and demand. Here, it is worth pointing out that the increasing need for better public transportation will be driven by rising national and international populations, increasing demand to reduce dependency on fossil fuels, lowering prices of alternative energy and technologies, and slow but steady social behavior shifts forcing more and more people towards alternative lifestyles that diminish personal car ownership. That's all for today. Thanks for watching. If you enjoyed, smash the like button and share it with your friends. Thank you for being here. See you in the next video. Until then, peace out.